This is a continuation of the last section, 4.7. And what we have are just more exercises that are very similar to what you're going to do in your MyMathLab. So how do we find, so the first exercise here is to find an antiderivative for each function. Do as many as you can mentally, it says here, and then check your answers by what? Differentiating. So once you take the derivative of your antiderivatives, you should be able to get these for your derivatives. So let's go ahead and work on letter A. The antiderivative of 5x to the fourth is, what do you think? Can you do it in your head? Right, so that's going to be 5x to the fourth. So really, it's really just 5 times x to the fourth. So you apply the power rule just like you do with the derivative, but this time you add instead of taking off, and then you don't bring down, but you write it as 5 times x to the fifth over 5, and that cancels out, and so your antiderivative would be equal to x to the fifth plus a constant. Again, how do we know whether this is the right antiderivative? Take the derivative of x to the fifth plus c. That's going to be 5x to the fourth plus 0, which is just 5x to the fourth. Now let's do letter B. Alright, so that's just x to the 12 divided by 12, because you just add one exponent 1 degree higher and divide that degree and put it in the denominator, plus a constant. So again, how do we check? So we take the derivative. So if we differentiate, what do we have? We'll have, so differentiating, you'll get, just to check. So to check, we differentiate, we get 12 times x to the 11 divided by 12 and plus 0, and so you get x to the 11th. Let's take this letter C. So what do we do with letter C? We just take the antiderivative term by term. So that becomes x cubed over 3 minus, this is going to be 6x squared over 2. So really what you've got is a 3x squared minus 7x plus a constant. And see how, just the best way to do is just check term by term. What is the derivative of x cubed divided by 3? Well, it's x squared, because you bring that 3 down, it becomes x squared. 3x squared over 3, that cancels out, so you get x squared. And then see, differentiate, you get 6x, and then the derivative of 7, negative 7x is minus 7. So that takes care of example 1 or exercise 1. Do the same thing here, but what we do is rewrite everything that's in the denominator, and if there's just a constant here, write this using your power rule. So this becomes x to the negative 4. This is 3 times x to the negative 4. So it's really just the same. It's just that they have a constant here, and that's practically the same thing as well. So it's 2 minus 3x to the negative 4. Okay, so when we designate, or we denote capital G of x as the antiderivative of g. So what do you do? That's just x to the negative 3 divided by negative 3 plus a constant. So again, differentiate, that's the way to check. If we differentiate this, bring down the negative 3, that cancels out the negative 3 at the bottom, and then take off take negative, or add negative 1, or take off 1 from negative 3, and we get negative 4. So what is the antiderivative here? Well, you'll just have to multiply this by 3, so that comes up to be 3x to the negative 3, whole thing divided by negative 3 plus a constant, which leads us to have that since this would simplify, it'll be the negative of x to the negative 3 plus a constant. And then what about C? Well, it's just this, add that, so you have 2x plus x to the negative 3 plus a constant. And again, the best thing to do is differentiate to check. So always check by differentiating. So check by differentiation. Let's continue. Find an antiderivative of this function and when c is 0. Now what does that mean when c is 0? That means you just, once you get your general antiderivative, then replace c by 0. So we'll write the antiderivative therefore would be negative 10. Okay, so with the negative it'll be minus cosine of 10x, and then whole thing will be divided by, that's your case, so you have a 10 here. Okay, the whole, that would, so see how you have a negative and a negative, and that would cancel out each other, plus a constant. So you're gonna really have as your final answer would be, so that would also be negative times negative is positive, so your final answer would be cosine of 10x. And then since c is 0, that's it. That's your antiderivative. And again, how do we do that? Check. What is the derivative of cosine? Negative sign. Then you have to multiply by the derivative of the inside. What's the derivative of 10x? 10. So that's how you get your little f of x. Next, number 4, find an antiderivative of the function h of x equal to the negative cosecant squared of 9x over 7. So the first thing you have to find out is to remember, what is this a derivative of? That's the question. So what is this? Well, just recall, this is the derivative of cotangent. So all we have to do is write it as cotangent of, what is it? 9x over 7 divided by 9 over 7, because you know that's that k right there is 9 over 7 plus a constant. And then how does that come out to be? Well, that's just 7 over 9 cotangent of 9x over 7. Now remember, these cannot cancel out because this is a single term. They do not, this is not the same as cotangent times 9 times x over 7. No. Cotangent of this whole thing is one single term. So this is just a constant multiplied to a single term. So these should not cancel out each other. And plus your letter C. Then how do you check? Differentiate. So what is the derivative of cotangent? Negative cosecant squared of the argument. Then use chain rule multiplied by 9 over 7 and see how those things cancel out, and you're back to your little h. Alright. So here, this is the same as taking the antiderivative, but now we're just using the integral sign. So what is the antiderivative? Is taking the integral of all of this. So first of all, let's rewrite it as what? This is the integral of x to the negative 4 minus x to the 4 minus 1/9. Okay? Then multiplied by all thing by dx. So this is equal to, just take the antiderivative term by term. So that's going to be x to the negative 3, because you add divided by whatever is in here. So whatever's there divided by negative 3. Now you've got a minus x to the 5th divided by 5. And then what is the antiderivative of a constant? Don't forget that this is a slope. So it's the line. So it's minus 1 over 9x plus c. Again, there's always safe when you're taking the antiderivative or the indefinite integral. It's always safe to check your answer, because you can always differentiate. And when you differentiate, you should get back whatever is inside the integral sign. Alright, so find the most general antiderivative or indefinite integral of this one. what do we do here? We rewrite this as the integral of 9 times x to what? Raised to a fifth dx. And what do we do from here? Just use the power rule multiplied by a constant. So that's just 9 times x to the add 1 to 1/5. What do you get? You get 6 over 5 divided by 6 over 5 plus a constant. So what is that? That's 9 times 5 over 6. Okay, x to the 6 over 5 plus a constant. Keep going by simplifying. Then you have 3 times 5, that's 15 over 2, x to the 6 over 5 plus c. And again, the best thing to do is take the derivative. So once you take the derivative, you should be able to get this right here. All right. Now, here is a very interesting part of solving, looking for antiderivatives. It's with what we call initial value problems and differential equations. Okay, so remember that when we have a function before, when we started with chapter 3, we have a function y, right? So we have a function y. So in chapter 3, if you remember, so we have a given y is a function of x. Let's just call it, okay, a function of x. Then we take the derivative dy by dx. We get another function. Okay, so this time, what if this is what's given? So you have now what we have now is a situation where we have a differential equation. So a differential equation is really just saying that if you're given a derivative, which is a function, and then it has the original, we want to find out what is the original function to begin with, what was y, given an initial condition. That means when at x equal to 0, you plug in y, you get y sub 0. Now, how do we solve this? Well, if you know how to take the antiderivative, then that will give us the general solution to this differential equation. So suppose y is equal to that f of x plus c, which is the general solution. So that's what we've been doing so far, right? So now we find, in step 2, we find the particular solution that satisfies the initial condition. In other words, what will this c be so that it will satisfy the initial condition? So by substituting x sub 0 into your function, and then y sub 0, then we'll be able to solve for the particular value of c. Okay, so let's take this for example. To solve the following initial value problem, so this is our initial value problem, right? Okay, how do we do that? This is your given differential equation, and then this is now what we call our initial condition. In other words, the initial condition is when x is equal to 0, s of 0 is equal to 4. So what we're looking for is the s of t, given ds by dt. Let's go ahead and do that. So let's see, what are we given? Our differential equation, ds by dt is equal to 1 plus cosine of t. And then what's your initial condition? S at 0 is equal to 4. So what we'll do is take this derivative, and then take the antiderivative of both sides. Really, that's what you're doing. So what is the antiderivative of a derivative? You just get back the original function. So s of t is equal to, what's the antiderivative of 1? T. What's the antiderivative of cosine of t? Sine of t. But this is the general solution. So we always add the arbitrary constant c. How do we find the particular solution? We use the initial condition. to find the particular value of C. So the initial condition is that when t is 0, s is equal to 4. So this is all you have to do is, okay, s of 0 is equal to 0 plus the sign of 0 plus c. But what is s of 0? It's equal to 4. So 4 is equal to, what's the sign of 0? It's 0. So 4 is equal to 0 plus c. Therefore, c is equal to 4. So that tells us that the particular solution that solves this differential equation would be s of t is equal to t plus sine of t plus 4. And how do we know whether we got the right answer? Differentiate. So to check, always check. Okay, to check what is ds by dt, it's equal to 1. That's a derivative of t with respect to t is 1. And the derivative sine of t is cosine t. And then take s of 0. What is s of 0? S of 0 is 0 plus 4 is equal to 4. So indeed, this is our solution to our differential equation because it satisfied the differential equation as well as the initial condition. Here's the last one. Solve the following initial value problem. And then it says here to type an exact answer using pi as needed. Alright, so what is our differential equation? That's the given. So let's look at the given. We have our differential equation would be dr by d theta is equal to pi cosine of pi theta. And then our initial condition is that r of 0 is 2. So let's go ahead and get the general solution. So what is the general solution? Since this is the derivative, that means r of theta is equal to, just take the antiderivative the right side. So what is the antiderivative the right side? It will be the negative of cosine, the negative of sine of pi theta. And then remember there's pi here, so let's start over. So r of theta is equal to pi times, what is the antiderivative of cosine of pi theta? It will be negative, or rather positive sine of pi theta, whole thing divided by pi, plus a constant. So cancel that out and then check out. If I differentiate it, will I get this? Yes. So now we've gotten the general solution. So to get the value of c, apply the initial condition. So when theta is equal to 0, r is equal to 2. So plug in r equal to 2 right here. So 2 is equal to the sine of pi times 0 plus a constant. So what is that? That's just sine of 0 is what? 0. So c is equal to 2. So the solution, therefore, the particular solution that satisfies the initial condition would be equal to r of theta is equal to sine of pi theta plus 2. And that can easily be checked because this is now the solution that satisfies, okay, so this particular solution satisfies this differential equation with this initial value problem. And that's the end of section 4.7. Now, what's next? Do your homework. Enjoy, have fun. Happy turkey. And be thankful, not just on Thanksgiving Day, but every day.